and good evening to all of you. So let's here discuss about the concept of discharge and volume flow rate, which we have discussed, which we are learning in fluid mechanics chapter. So here is the concept. Here is the concept. Suppose let's fluid is flowing. Let's fluid is flowing in certain direction. In certain direction, we have to take an imaginary area. We have to take an imaginary area. Let's suppose we have to select a small dA element here. We have to select a small dA element here. What is this dA element? Because this body is this surface area, this whole area are made up of very small chotu element known by the name dA element. Means a small area we call it as a dA element, means dA. Suppose, for example, what is the meaning of discharge or volume flow rate? Discharge or volume flow rate means volume, the volume flow through certain area in unit time is known by the name volume flow rate, or sometimes this representation is given by Q. This representation is given by the symbol Q. We have to select a small dA element. Let's suppose, for example, if a volume, we talk about the volume. If we talk about the volume, means we have this chotu element called dA. And suppose this fluid travel a ds distance. Travel a ds distance here. This fluid travel a ds element. This fluid flow through a ds distance. What is the volume? This imaginary cylindrical volume. What is the volume of cylindrical? This area into length. Area into length means dA into ds. So suppose in a dt time, the volume flow through that area is dA into ds. Unit time means only A1. Means when we divide dt on both sides, we will get dA into ds by dt. Means the question is that what is the ds by dt? What is the ds by dt? Suppose we have an area. Suppose the fluid is flowing in this direction. Let us name them V. We have two components. One component is along the direction of ds. One component is along the direction of ds, that we call as normal component. This is Vn. And one component which is perpendicular to the flow direction, we call as tangential direction. We call as tangential velocity. And the velocity which is along the direction of flow, we call as a normal velocity. But remember one thing, only the normal component of velocity is responsible for discharge. Suppose if we are standing, if a cockroach, let us suppose if we are standing on a floor of lift and we want to come out from the lift, we always move along in this direction. Means why we would not taken the velocity which is tangential to the surface of the lift, that is tangential to the surface of lift, because that's why we already know that only the normal component of velocity is responsible for discharge or flow of fluid in that area. So in this ds by dt is nothing, it is a normal area. This is normal. Vn means only those component of velocity, only normal component of velocity is responsible for fluid to be flow. Ds by dt means Vn. They call as in a unit area. This discharge is nothing. It is a Vn into dA. But we have a very small area. The flow can takes place through a very small area dA, and the normal component of velocity which is perpendicular to that area, that is Vn into dA, and Vn into dA is nothing. It is called, known by the name discharge. Means Q. What is dQ? Not a Q, because the discharge is very small. This discharge is very small because the area must be very small. Area should be very small. Then dQ is nothing. It is a Vn into dA. Vn into dA means, let's integrate to know about the full discharge through that area, through that red area. We integrate that Vn into dA. This dQ integration is Q. This is Vn into dA. But we in class 11th we directly apply Q is equal to AV. That is the law of conservation of mass. That law of conservation of mass, A1 V1 is equal to A2 V2. We can't use it directly. Q. Why? Because if Vn is variable, if Vn has two possibilities. If Vn is variable, we have no other choices. We should integrate it. Means we have two choices. If Vn is variable, if Vn is a function of x, Vn is a function of s, Vn is a function of x, means where the fluid is flowing. If Vn is variable, we can find the discharge by using this formula, Vn into dA. If normal component of velocity is constant, if normal component of velocity is constant, then we can use this formula, Vn into dA, and we know that Vn is constant. It comes out through that integration, means Vn and integration of dA. What is the integration of dA? We already know that. Means integration of chotu. Integration of very small area, we call it as a Vn into A. But today onwards, we always use Q is equal to AV if that area, if in that cross section, if velocity is not varying, then we can use direct formula, Q is equal to A into V. V is always the component of velocity which is along the flow direction. We have to put that velocity here. Then the formula Q is equal to AV. Means, what is the meaning of discharge? Meaning of discharge means how much volume flow in a given area in a unit time. Means in a given area, how much volume flow through that area in a unit time, we call as a discharge, and that is known by the name volume flow rate. Rate means when something is divided by time, then we call as a rate. Means the formula Q is equal to AV. Derived in this direction, in this way. So thank you for knowing the concept discharge and volume flow rate, and later on I will discuss about the concept of average velocity and mass flow rate. Thank you so much.